Hi, I am Gerimae. I'm going to report the the under of probability, which is section 3.4 addition topic in probability and counting. So the objectives: first, how to find the number of ways a group of objects can be arranged in order. Second, how to find the number of ways to choose several objects from a group without regard to order. Third, how to use counting principle to find probabilities. So, first, for permutation. Permutation and order a range of objects. The number of different permutation of n distinct objects is n factorial is equal to n times n minus 1 times n minus 2 times n minus 3, so on and so forth. 0 factorial is equal to 1. Example, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. The second example, 4 factorial is equal to 4 times 3 times 2 times 1 is equal to 24. Example, the objective of 9 times 9 Sudoku number puzzle is to fill the grid so that each row, each column, and each 3 times grid contain the digit 1 to 9. How many different ways can first row of blank 9 times 9 Sudoku grid be filled? Solution. The number of permutation is 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 362,880 ways. The second, permutation of an object taken R at a time. The number of different permutation of n distinct object taken R at a time is equal to n probability of R is equal to n factorial. These are the formula is equal to n factorial over n minus r factorial, where r less less than less than n. For example, find the number ways of forming 4-digit codes in which no digit is repeated. Solution: you need to select 4 digits from a group of 10, which is n is equal to 10, r is equal to 4. So here, distribute the formula, and the answer is 5,040 ways. Example, each year 33 race cars start the Indianapolis 500. So, and how many ways can cars finish first, second? So, the N is 500 and the R is 33. So you need to select 3 cars from a group of 33. So N33, R is equal to 3. So distribute the formula of permutation and permutation of R, subscript of R. So the total of 32,736. Distinguishable permutation. Distinguishable permutation, the number of distinguishable permutation of an object where n1 are of one type and 2 are of another type, and so on. So here are the formula. N factorial over n factorial 1 times n1, n2 factorial times n3 factorial, so on and so forth. Example, a building contractor is planning to develop subdivision. The subdivision consists of 6 one-story houses, 4 two-story houses, and 2 split-level houses. In how many distinguishable ways can the houses be arranged? Solution. There are 12 houses in subdivisions. Uh, s- uh, 6 times 2 is 12. Or so n is equal to 12 and n the given n is equal to 12 n minus n 1 is equal to 6 n 2 is equal to 4 and n 3 is equal to 2. Then distribute the formula of distinguishable permutation. 12 factorial over 6 factorial times 4 factorial times 2 factorial, the total of 13,860 distinguishable ways. Combination. Combination of n object taken r at time, a selection of r object from a group of n object without regard to order. N combination of n and r is equal to n factorial, the formula of combination of n object taken r at the time. So example, a state department of transportation plans to develop a new section of interstate highway and receives 6 beds for the project. The state plans to hire 4 of the bidding companies. How many different combination of 4 companies can be selected from the 16 bidding companies? Solution. You need to select 4 companies from a group of 16. N is equal to 16, R is equal to 4. Order is not important. So the formula of combination of n object taken are a time is equal to 16 factorial over 16 minus 1 factorial 4 factorial times 4 factorial. So i-distribute mo ito nimo ang combination per formula. Then is equal the total of the different combination total of 1820. The summary of counting principles here. Principle. Fundamental counting principle. Description. If one event can occur in m ways and second event can occur in n ways, then the number of ways the two events can occur in sequence m times n. Permutation. The number of permutation of n distinct objects. The number of permutation of n distinct object taken r at time. Where r less than not less than n the number of distinguishable permutation of n objects where n1 are one type n2 are another. So combination the number of combination of r objects selected from a group of n object without regard to order. Where so that's all. Thank you.